Okay, hello everyone. You are all welcome to this video. I remain your tutor, Mr. Life Changer. Here I'm going to be solving a past question, a waec past question, 2011 to be precise. And I downloaded this copy from myschoolgist.com. Okay, so but this is for the purpose of this video, just to help you practice, towards your exams. And some of the questions you would see, and some of and will make you a better student. Okay, so we start with the first one. The mass of an object can be measured using the following instruments, except now all of them can be used to measure mass except the meter rule. Okay, they all have spring balance, can use to measure weight particularly, but you can always convert weight to mass. And the same with lever indirectly, beam indirectly. Now the second question says a load of 80 newtons extends a spring by 8 centimeter. When the load is replaced by a copper block, the extension produced is 10 centimeter. Calculate the weight of the copper block, assuming that the elastic limit of the spring is not exceeded. According to Hooke's law, as long as the elastic limit is not exceeded, the force applied is proportional to the extension. So I can also say F1 over F2 is equal to E1 over E2. So F1 is the initial force. In this case now it is a weight, the load, that is 80 newtons, over F2, that's what we want to find. Now E1 over E2, this is 8 centimeter, this is 10 centimeter. Now I don't need to convert because they can always cancel out. So this is 8 over 10 centimeter, centimeter cancels centimeter. So from here you're going to now have that your F2 is going to be equal to 10 times 80 divided by 8, and that will be 800 divided by 8, which is equal to 100 newtons. So the answer to this question is C, 100 newtons. Now that leads us to the third one. Okay, this one says that a sample of air weighing 1.32 times 10 raised to the power 3 newtons is confined in a room measuring 9.5 meters by 5.0 meters by 2.0 meters. Calculate the density of the sample. Okay, so in this case here, I'm going to use we are given the weight of the sample, and we are given the volume, and we are given acceleration due to gravity, and we are asked to find density. Okay, density in this case here is equal to mass over volume, right? Yeah, mass over volume. Now, so since the weight is 1.32 times 10 raised to the power 3, it means that the mass is going to be the weight divided by acceleration due to gravity. Since we know that weight is supposed to be mg, mass times acceleration due to gravity. So the weight is 1.32 times 10 raised to the power 3 divided by acceleration due to gravity is 10. So this would be 1.32 times 10 raised to the power 2, okay, kilograms. Now we can find the density. Density mass, which is 1.32 times 10 raised to the power 2 divided by the volume. Volume is 9.5 times 5, so it's going to be 9.5 times 5.0 times 2.0. So this is already 132, and this time this is going to give us 95. So I have my calculator here. 132 divided by 95 is 1.39. So 1.39 kilogram per meter squared is the answer. So the answer to this question is C. Quite easy, right? Now the next one says a turkey stands and makes 4 times 10 raised to the power minus 2 meters squared of contact with the ground. Okay, if the pressure it exerts on the ground is 2.8 times 10 raised to the power 8 Pascal, calculate its weight. Okay, now in this case here we can say that the pressure is force all over area. The force in this case is his weight. Okay, so that means the force is going to be equal to pressure times the area. The pressure is 2.8 times 10 raised to the power 3 multiplied by the area is 4 times 10 raised to the power negative 2, and that is going to give us 2.8 times 4 is this is 11.2 times 10, so that's 412 newtons. That's the answer. So C is the answer to that question. Quite easy, right? Now this one says number 5. It says the graph above illustrates the motion of two cars P and Q over a period of time T. Okay, which of the following statements about the motion of the cars is correct? You can see this is a graph of velocity against time, right? So and whenever you see a horizontal line, it means a uniform velocity. So A says P is correct. P accelerates faster than Q. No, they have the same acceleration. Because they are horizontal, both of them has an acceleration which is equal to 0. Because when a car or when an object is moving with uniform velocity, the acceleration is definitely equal to 0. So A is not the answer. B says has more horsepower than Q. Let's see, has more horsepower than Q. We may not be able to conclude with that yet, but we know that P has a higher velocity than Q. Okay, C says has the same acceleration as Q. Yeah, that's the best answer here. They have the same acceleration because both of them has acceleration equal to 0. Then D says and Q increase their speed steadily. No, none of them increase speed. Both of them are horizontal. So the answer is C. They both have the same acceleration, right? Okay, so that makes sense. Now the next one here says when a projectile is projected with an initial velocity u at an angle theta to the horizontal component of its velocity is, the horizontal component is ux, is u cos theta. That's the answer, which is A. The vertical component is uy, that one is u sin theta. Okay, so the answer to this question is A. Now the next one here says that a body of mass 200 grams moving at 15.0 meter per second is accelerated to 25.0 meter per second in a time of 10.0 seconds. Okay, use the given data to answer the questions number 7 and 8. Okay, so the first one says determine the magnitude of the accelerating force. Whoa. Okay, first of all, we are given the mass to be 200 grams. 200 grams means 0.2 kilograms when you divide by 1000. Then there is a change in velocity. You have the initial velocity to be 15.0 meter per second. Then you have the final velocity to be 25.0 meter per second. And the time here, t, is equal to 10.0 seconds. So since we are asked to find the force, the accelerating force is just mass times acceleration. Now, we are not given acceleration, but we can calculate the acceleration because acceleration is change in velocity over time. Now the final velocity is 25, the initial is 15, then the time is 10. So that would be 10 divided by 10, I guess, and that's equal to 1. So the acceleration is 1. So when you say mass times acceleration, the mass is 0.2, the acceleration is 1, so that's going to still give us 0.2 newtons. So A is the answer to number 7. Now number 8 says, calculate the amount of work done on the body. The amount of work done on the body. Work done is always force times distance. Okay, but in this case, if you notice, distance is not given. So you can say that the work done on this body is a kinetic energy. That's one way you can solve that. You can say, since there is a change in velocity, you can say half m, then v squared minus u squared. Okay, we can use this. And so that would be half times the mass is 0.2, v squared, that's 25 squared minus 15 squared. Okay, so this is 0.1 times 25 squared is 625, 15 squared is 225. So this is 0.1 multiplied by, this is 400, and that will give us 40 joules. So 40 joules is the answer. Now another way you can solve this, you can also say work done is force times distance. Okay, you can find distance. Distance is simply average velocity times time. That means u plus v over 2 times time. Yeah, this is correct. Okay, so the initial velocity is 15. final velocity is 25, then over 2 times the time we are given here is 10 seconds, so we can use that here. So 15 plus 25 is 40. 40 divided by 2 is 20, right? So 20 times 10 is 200. So the distance is 200. So I can now say that work done is equal to force times distance. Force is 0.2, distance is 200, and that gives us 40 joules. So you see, so as long as you know your formulas, you can always manipulate them, right? So that's the answer for that one. Now we go to the next one. The next one says the magnitude of the resultant of two forces inclined at an angle 30 degrees is greater than the magnitude of either forces, equal to the sum of the magnitude of the two forces, equal to the difference in the magnitude of the two forces, and greater than the sum of the magnitude of the two forces. Okay, first off, when you have two forces that has an angle of 30 degrees in between them, the resultant of the force is going to be square root, first off, okay, of f1 squared plus f2 squared plus 2f1 f2 then cos theta. So that's cos theta, whatever angle is between them. Now there is no way that this is will not be bigger. It's definitely going to be bigger than what do we have, than each of the forces, right? By the time you find the resultant, you can use any value. Let's assume that F1 is 2 newtons and F2 is 3 newtons. You don't have time to do all this in the exam hall, but looking at plus, as a mathematician, when you look at this, you can figure out that this is definitely greater than this. But if we say this is 2, this is 3, and I substitute here, it's going to be 2 squared plus 3 squared plus 2 times 3, then cos 30. Okay, so I'm going to use my calculator to do that quickly. So we have 2 squared plus 3 squared, then plus 2 times 3, then cos 30. So the answer is 4.84 newtons, you see. So 4.84 newtons is the resultant force. It is greater than 3 and also greater than 2. So quite important. So you can say A, greater than the magnitude of either forces. The magnitude of greater than the magnitude of either forces. Yeah, that's the answer. Okay? And it is not greater than the sum of the magnitude of the two forces. No, because 2 plus 3 is 5. No, this is not greater than this. Equal to the difference in the magnitude of two forces. No. 3 minus 2 is 1. Is not equal. You see that? Equal to the sum of the magnitude of the two forces. Okay? So the sum is already 5 and it is not equal to this. So the answer is A. It is greater, right? Than the magnitude of either forces. It is greater than 3 and also greater than 2. Beautiful. So that leads us to the next question. It says, a uniform meter rule balances horizontally when it's pivoted at the 70 cm mark and a mass of 105 grams is suspended at the 90 cm mark. Okay, calculate the mass of the meter rule. Now the word uniform meter means that the center of gravity is at the center. So I'm going to have something, and that's where the weight is. So let's say it's a uniform meter rule, meaning that the reading is from 0 to 100 centimeter. And the weight must act exactly at the center, which is at the 50 cm mark. That's the weight of the meter rule. Now, and 50 cm, that's at the center, between 0 and 100. Now, a mass of 105 grams, okay, it is pivoted at the 70 cm mark. So somewhere around here, which is 70 cm mark, it is pivoted, right? And a mass of 105 grams is suspended at the 90 cm mark. So 90 is close to 100. I'm going to put it here. You have the 105 grams at the 90 cm mark, right? So we are asked to find the mass of the meter rule. Now, whenever we encounter a question like this, a formula should come to our mind. First of all, that some of the clockwise moments equal to some of the anti-clockwise moments. If you notice, this load here is towards the pivot. Towards the pivot, it is moving anti-clockwise. This load towards the pivot is moving clockwise in the clockwise direction. So all we need to know is to find the distance between this load and the pivot and this load and the pivot. Since this is 50 and this is 70, the difference is 20, the gap is 20. And since this is 70 and this is 90, the gap is also 20. Ooh. Okay, nothing much. So clockwise moments is 105 times 20 equal to anti-clockwise moment is W times 20. So since this is 20 and this is 20, the weight is definitely equal to 105. That's amazing. 105 grams. If you notice, I didn't do any conversion because the units are consistent, so no need to convert. Now that leads us to the next one. Which of the following motions is not simple harmonic motion? Okay. A, the motion of a particle in a transverse wave. Okay. B, the vibrating prong of a tuning fork, of course. C, a simple pendulum swinging in a large angular amplitude. D, the vertical vibration of a mass at the end of a spring. The vertical vibration of a mass at the end of the spring. This is definitely a simple harmonic motion. Now all of them actually, looks like a simple harmonic motion, except for the first one. The first one is a wave motion. The vibration of prongs of a tuning fork is actually produces a wave motion, which is sound, but the vibration itself is a simple harmonic motion. Okay, so the answer to this question is A. Now the next one, number 12, says a pendulum clock keeps a wrong time when the room temperature rises substantially. This observation is due to keeps a wrong time when the room temperature, okay, increase in a period or as a resultant of increase in the length of the pendulum, okay, decrease in a period due to increase in the length of the pendulum. Okay, so this is a pendulum clock, and when the room temperature increases substantially, something happens. Now, first of all, when the room temperature increases, it is expected that the length of the pendulum is going to increase because of increase in temperature will increase the length of the pendulum. That's that's correct. Now, but you should know that the period of a simple pendulum is actually supposed to be equal to 2 pi root L over G. That's the formula for the period on a simple pendulum. And so the period is directly proportional to the square root of the length. So that means if the length increases, the period should also increase. So the answer is A, an increase in period as a result of an increase in length of the pendulum. Yeah, common sense, right? Now, the reason why the length will increase at room temperature is you should remember expansivity. Whenever there's an increase in temperature, whatever it is, the materials expand, when temperature is increased. I hope that makes sense. Now the next one says jet and rocket propulsions are based on Newton's third law of motion. I don't need to think about that, okay, because for a jet to move, there is this fire that comes. Let's assume this is a jet. It releases fire for it to move upward, and that's the same thing with rocket propulsion. Okay, yeah, Newton's third law of motion. To every action there is an equal but opposite reaction. Now the next one says when the average separation of a molecule of a fixed mass of gas of an ideal gas is increased, there is corresponding average. Now when the average separation of the molecule of a fixed mass of gas is increased, okay, so what that means is that it is going to increase the rate of collision. Not really. Decrease in pressure of the gas. When the average separation, okay. C says increase in the kinetic energy of the gas. No, this is not going to happen. D says decrease in the number of molecules. No, the molecules will remain the same. The answer to this question is B, decrease in pressure of the gas. Now, the simple reason is that when the gas molecules, when the separation is very close, there will be more collision with the wall of the container. But when it is expanded, there will be less collision, and pressure is as a result of collision with the wall of container. Okay. Now look at this one here. It says calculate the lifting force acting on the block. Oh, okay. The lifting force, the force that lifts this up. We are supposed to use this, study the diagram above, and use the information provided to answer question 15 and 16. Now, the lifting force, first of all, this force is acting at an angle 60 degrees. This force has a vertical component, which is what we call the lifting force, and it has the horizontal component, Fx. So the lifting force is the vertical component, which is Fy, and which is equal to F sine theta. Okay, so your F here is 25, then sine theta, that's sine 60. So that is going to be 25 times 0.866, and 25 times 0.866, even though that is easy to solve, is 21.67. So this is 21.67 newtons, and that is equivalent to this 21.7 newtons. Beautiful. Physics is interesting. Now the next one says calculate the work done in moving the block to point B. Now whenever you are pulling an object at an angle, the work done in moving that object, work done, is equal to the force times distance, then cos the angle of pull, right? Yeah, you should know this. In case you don't, now you know. Okay, so work done is force times distance, but whenever the object is pulled at an angle, it is Fs cos theta. So in this case now, the force is 25. The distance of pull, you can see, is 3.2, then times cos 60. Cos 60 is of course 0.5. So I'm going to have, 25 times 3.2 times cos 60 is going to give us 40. So the answer is 40 joules as the answer. So C is our answer here. Ta-da! Okay, that leads us to the next one, number 17. It says a student pulls a trolley with a horizontal force of 50 newtons through a distance of 1.5 kilometers in 20 minutes. Calculate the average power. Okay, now power can be work done over time, yeah. And so work done can be force times distance, then over time, yeah. So this makes sense, right? So, but the only problem is that this distance and time is not in SI units. So 1.5 kilometer is the same thing as 1,500 meters, because kilo means 1,000. So 1,500 meters. Then 20 minutes, to convert it, it means 20 times 60. So that would be 1,200 minutes, right? I mean seconds, yeah. So using this formula now, the force is 50. The horizontal force, the distance is 1,500. Divided by this is 1,200. So I'm going to have 50 times 15 divided by 12. So this is giving us 62.5 watts. Beautiful, easy, right? Now the next one says, when a bicycle is being ridden uphill, its mechanical advantage is, now when you say uphill, just like on an inclined plane, right? Yeah. And you should know that first of all, the velocity ratio of an inclined plane, is equal to sine theta. Is it sine? No, sorry, tan theta. It is 1 over sine theta. Okay, I will need to confirm that quickly. Permit me to confirm that. Yeah, but I think it's 1 over sine theta. I don't think I made a mistake there. Okay, so that is quite easy. And so our mechanical advantage, yeah, the velocity ratio is 1 over sine theta. Mechanical advantage is always load over effort. Okay, So it is saying greater than 1, less than 1, equal to 1, equal to its VR. Of course, it cannot be equal to its VR, because if you want to calculate the efficiency, it is mechanical advantage over velocity ratio. Okay, so and when you say 1 over sine theta, let's assume theta is 30 degrees. You're going to have 1 over sine 30, which is going to be 2. So definitely 1 over sine theta is definitely greater than 1. Definitely greater than 1. From 1, definitely greater than 1. Okay, and so for this to be greater than 1, right, it means that this guy now should be either equal to 1 or less than 1. That's for the mechanical advantage, in order for it to give us what we want. So the answer to this question is that mechanical advantage has to be less than 1. Okay, has to be less than 1. Actually, the my answer would have been has to be less than the velocity ratio. Okay, yeah, very important. And now that leads us to the next one. The SI unit of temperature is Kelvin. We don't need to think about that. Now I know you are going to have a confusion here for F and C, but temperature is degree Celsius, not C, and is also degree Fahrenheit, not F. So that's why we cannot choose A or B. So the answer is K, Kelvin. I hope you know that. And moreover, out of all of them, the SI unit is Kelvin, right? Yeah, SI unit means standard international unit. Now the next one here says, which of the following application is not related to thermal expansion, second of telegraph wire, gaps between rail, anonymous expansion of water from 0 to 4 degrees, use of a thermostat? Okay, the answer is this one here. Okay, which of the following application is not related to thermal expansion? Yes, anonymous expansion of water. Instead of expanding between 0 to 4, it actually contracts. That's why it is called anomalous. But we use expansion in thermostat, we use it in gaps between rails, we use it in sagging of telegram wires. These are different applications of expansivity. Now the next one here says an air bubble of volume this 4 times 10 to the power minus 6 meter cube formed 5 meters below water surface moves upward. Determine the volume just before it reaches the surface. Okay, and before reaching the surface, so you have volume and you have height, right? And now I want to say this, that height represents pressure. If you notice here, it says assume the temperature remains constant, atmospheric pressure equal to 10 meters of water. You see that? So height represents pressure. What this question is just trying to get us to see is what we call Boyle's law. And according to Boyle's law, V1 P1 is equal to V2 P2. So remember that some pressure can be measured in terms of height. One of the formula for pressure, especially of gases and liquids, is rho GH. Rho is density, G is acceleration due to gravity, H is the height. And if you notice, we are dealing with water here. So the density is constant, acceleration due to gravity is constant. So we can represent pressure in terms of height. Right? So your V1 here is 4 times 10 to the power minus 6. The pressure here is 5 meters below the water surface. That's the height or the depth, because this H here actually represents depth, not height. Now V2 is what we are looking for. P2 here is 10. That's at the top, at the surface, right? So that means V2 now is going to be 4 times 10 to the power minus 6 times 5 divided by 10. That is going to give me 2 times 10 to the power minus 6 meter cube. That is the answer to the question. Okay, we don't have 2 times 10 to the power minus 6, but I just remembered that the bubble is formed 5 meters below the water surface, moves upward, determine its volume just before it reaches the surface. Okay, now I would like to say this just to, now when it was below the surface, it was 15 because of 10 plus 5. Once you see an object below, The pressure it experiences is the atmospheric pressure, P atmospheric, plus the pressure inside the water. Yeah, so please note that. So that is why this should be 15. Then, but at the surface is experiencing only this pressure, which is 10, which is the atmospheric pressure. So whenever you see bubbles on the surface or anything on the surface, the only pressure they experience is the atmospheric pressure. But inside is the atmospheric pressure. We call it the absolute pressure. Absolute pressure is equal to atmospheric pressure, which is PO or PATM, then plus the pressure, the gauge pressure, or what you call the pressure of the liquid. So this is supposed to be 15. So this is 15. So let's calculate that quickly. So 4 times 15 is 60. Okay, so this is 6 times 10 to the power minus 6 meter cube. Yeah, so D is the answer. I almost made a mistake there. Now the next question says, an aluminium calorimeter without lid and jacket is placed on a table. Boiling water is then poured into it. Which of the following processes will account for the cooling of the water? Okay, I read that again. An aluminum calorimeter without a lid, no cover, and jacket is placed on the table. Boiling water is then poured into it. Which of the following processes will account for cooling of water? Cooling of water in this case now has to do with heat transfer. So definitely there is an evaporation. Yeah. Definitely there is convection, because there is going to be heat loss by convection. That's basically it. But evaporation is definitely one of them. Conduction, through the it is not, the calorimeter is not lagged, so it can also lose heat by conduction, and it can also lose heat by radiation. So the answer to that question is D. Okay, so you have conduction because of the container. Once you have an aluminum container, the word aluminium tells you that it conducts heat, so it's going to lose heat by conduction. It's going to lose heat by evaporation, because some of the liquid will evaporate to the surrounding. It's going to lose heat by radiation. Radiation is a mode of heat transfer that does not need any medium. Yeah, because if you stand near the pot, you are going to be feeling the heat. The heat gets to you by radiation, and of course you are going to heat loss by convection. So D is the answer. Now number 23 says the quantity of heat required to raise the temperature of a unit mass of a substance by 1 Kelvin is known as specific heat capacity. Right? That is specific heat capacity. As long as it's a unit mass, it's specific heat capacity. If it was any other mass, it would have been heat capacity. Okay, the next one says, which of the following equation does not represent a traveling wave? Okay, this one does represent. This represents. There is nothing like this. This one here represents very well. These are 3 different ways we can write the equation of a traveling wave. So C is out of the question entirely. There is nothing like that. Now the next question says, which of the following diagram correctly illustrates the passage of white light through a triangular glass? Now first of all, B cannot be correct because it doesn't go up. The same thing with D, it doesn't go, it actually comes down this way, it refracts. When light passes through a prism, it always emerges this way. So it cannot be B and cannot be D, right? Then for this and this, we are going to consider the direction of the arrows. Okay. Now this is wrong also, because once it touches the glass, there's going to be a bit of a refraction inside the glass before it emerges. So the answer is C. There's definitely going to be a bit of refraction inside the glass before it emerges. The glass first of all refracts it, so that's very important. Now the next question says, the refractive indices of water and glass with respect to air are 4/3 and 3/2 respectively. If the speed of white light glass is this, calculate the speed in water. Okay, Now, you know that refractive index is supposed to be, okay, let me say refractive index as you go from glass to water is supposed to be the velocity of light in glass all over the velocity of light in water. And the refractive index from glass to water means refractive index of water divided by refractive index of glass. Yeah. So that means it's going to be 3. Okay, it's going to be 4 over 3 divided by 3 over 2. So that will be 4 over 3 times 2 over 3, and that's going to give us 8 over 9. So that means this is 8 over 9 and is equal to the speed in glass is 2 times 10 raised to the power 8. We want to find the speed in water. So the speed in water by cross multiplication is going to be 9 times 2 times 10 raised to the power 8 divided by 8. And this is going to give us 9 divided by 4. Let me consult my calculator. So 9 divided by 4 is going to be 2.25. So this is 2.25 times 10 raised to the power of 8 meter per second. So the answer is C. Okay, that is physics for you. So please note this. When you say refractive index from a medium to the other, it means refractive index of this medium of water divided by that of glass. That's how it works. Okay, please note that. Very, very important. Now the next one says optical fibers are based on the principle of I'm sure you know what optical fibers are. Give me a second. Are based on the principle of total internal reflection. I wanted to be sure, skipped my mind. Now the next one says when an object is placed 12 centimeters from a convergent lens, a real image 4 times its original size is produced. Calculate the focal length of the lens. Okay, now first off, there are 2 things you must note whenever you want to calculate. Use the mirror formula. We call it the mirror formula. The mirror formula is simply 1 over f equal to 1 over u plus 1 over v. Now, first of all, you must ask yourself, what kind of lens is it? Convergent lens. Since it is a convergent lens, it means that f is positive. F is positive. Then the kind of image formed. If it is the image is a real image, it means that v is also positive. You must be sure with this because for a converging lens, f is positive, but for a diverging lens, f is negative. For a real image, v is positive. For a virtual image, v is negative. So I have to be sure. Okay, so that means this is going to be 1 over f equal to 1 over u. The object distance is 12 plus the image distance, it says is 4 times. So it's going to be 4 times 12, which is 48. Now please note, assuming it was a virtual image, I would have put a minus here because v must be negative. Kindly note that. So now this is 48. 48 divided by 12 is 5. 5 plus 1 is 5. 5 times 1, sorry. 48 divided by 48 is 1. 1 times 1 is 1. So this is 6 over 48, or we can say, I think 6 can go in 48 8 times, I guess. How long? 3 here, 2, 3 here, 16, 2 here, 1, 2 here, 8. So this is 1 over 8. So 1 over f is equal to 1 over 8. That means the focal length is going to be equal to 8 centimeters. And now I wonder why we don't have an 8 centimeter here. Yeah, we did not make any mistake here. So 48 divided by 48 divided by 12 is 4. So sorry, 4 times 1 is 4. Yeah, so 4 plus 1 is 5. So forgive me. So 1 over f is 5 over 48. So that means f is supposed to be 48 divided by 5. So sorry. So this will be 9.6 centimeters. So C is the answer to that question. Now that leads us to the next one. Which of the following statements about sound waves are correct? Now, in a uniform medium, the intensity of sound wave is directly proportional to the distance from the source of sound. Yeah, intensity is definitely proportional to the distance. Actually, it is inversely proportional to the distance, not directly, so this is wrong. The amplitude of sound wave of a given frequency and wavelength is a measure of the energy of the wave. Yeah, this is correct. Pitch is the effect of frequency of sound waves on the human ear. Yeah, pitch is actually affected by frequency. So the answer is I, and I only. So which is A. So please, intensity is not directly proportional to distance. It is actually inversely proportional. The longer the distance, the lower the intensity. Now this one says for an astronomical telescope in normal adjustment, the distance between the lenses is, well, I wish I can draw this. An astronomical telescope consists of two convex lenses like this. Okay, and this is what we have. When you say normal adjustment simply means that the final image is at infinity, and for the final image to be at infinity, it means that I'm drawing this because I've forgotten. Okay, I can't remember exactly. So this, and where this image is formed, that means there will be a coincidence between FO and FE. Yeah, so from here to here is FO, and from here to here is FE. You are wondering, FO means focal length of the objective lens, FE means focal length of the eyepiece. So the answer is FO plus FE, so which is B. Now that's why it is important for you to know the foundation. You see, I just had to go straight to use my knowledge. Now the next one says the pitch of a musical note depends on frequency. We already saw that, right? Yeah. Then this one says two sonometer wire, X and Y, have the same length. If the mass per unit length is X is 1/9, and that of Y is 1/9 that of Y, okay? Determine the ratios of their frequencies of X to that of Y. Well, first of all, the frequency or the fundamental frequency of a wire, the formula is 1/2L times square root of T over mass per unit length. Now, if you look at this formula clearly, you will see that frequency is inversely proportional to the square root of mass per unit length. That means I should say that F1 over F2 is equal to square root of mu2 over mu1. Yeah, it's inversely proportional. So, of course, inversely means as one is decreasing, the other one will be increasing. Right? So, if the mass per unit length of X is 1/9 that of Y, what that means is that the ratio of X to Y is equal to 1:9. That's what it means. The ratio of X to Y is 1:9, right? Yeah, because Y is definitely greater than X. Since X is 1/9 that of Y, it means that the ratio of Y to X is 1:9. Now, if I want to find the ratio of the frequency, because it's inversely proportional, it will no longer be 1:9. It's going to be 9:1. It's going to invert. The relationship will invert, and there is also going to be a square root because of this square root here. So that is going to be 3:1. That's the answer, 3:1. Now, if you don't understand, some of you may understand what I just did now, but if you don't understand this, you can also use this formula. You can say F1 over F2 is equal to the mass per unit length of X of Y. You know, when you say 1/X that of 9, that means X is equal to 1/9Y. That means Y over X is equal to 9. That's what it means if you cross multiply. So in place of this is like FMY MX. This is FX FY. Okay, so this is already 9/1. So F1 over F2 would be square root of 9 is 3/1. You see, so the ratio of F1 to F2 is 3:1. And that's exactly what we chose here. So then that now leads us to the next one. The first resonant length of the air column vibrating in a tuning fork in a closed tube is 26.25 centimeter. The first resonant length of air column vibrating to a tuning fork in a closed tube is 26.25 centimeter. Neglecting end correction, calculate the frequency of the fork. Now, when we say first resonant length, now the first resonant length is what we call let's say this is the pipe and this is the length, 26.25 centimeter. The first resonant length here is going to be lambda over 4. Okay, that's the wavelength, lambda over 4, right? So that means lambda over 4 is going to be equal to 26.25. Okay, so that means lambda is going to be 4 times 26.25. You get it? Okay, so using my calculator, I have 4 times 26.25. That's going to give me 105. So lambda is 105 centimeter because this is centimeters. I can convert it to meters since this is in hertz. That means 1.05 meters. Okay, so and we know that velocity is supposed to be frequency times wavelength. So that means I'm looking for frequency. So frequency is going to be velocity over wavelength. So my velocity here is 336 and my wavelength here is 1.05. So 336 divided by 1.05 is giving me 320 hertz. So I go for it, right? Quite easy. Now the next one says the derived unit for the universal gravitational constant is, now you know that according to law of gravity, F is equal to G m1 m2 all over r squared, right? So making G a subject of formula is going to be it's supposed to be r squared. So this is fr squared over m1 times m2. The unit for force is newtons. R is distance, which is meter squared, over mass is kilogram times the other kilogram. So this will be Newton meter squared then per kilogram squared. That is it. Newton meter squared per kilogram squared. See, quite easy, right? Now the next one says static electricity is produced by either loss or gain of electrons. Loss or gain of electron produces static electricity. Now the next one says an insulated negative charge rod is held high above the cap of a positively charged electroscope. Okay, the rod is slowly moved towards the cap until it is just above it. The leaves of the electroscope will observe to slowly. Now look at this insulated negatively charged rod. The charge it is negatively charged and the electroscope is positively charged, so you definitely expect a collapse. So it is going to collapse completely. That's the answer. A is the answer to that question. It's going to collapse completely, right? So then we have this one. A total charge of 1.0 millicoulomb is stored by the capacitors in the circuit illustrated below. Okay, calculate the value of x. Okay, so for us to be able to calculate the value of x, remember that the same potential difference is applied across them and charge is supposed to be CV. Okay, so I think I can find x here because the potential difference across this is 100 volts. The potential difference across this is 100 volts because they are in parallel. So my charge is already 1.0 millicoulomb, means times 10 to the power minus 3 coulomb, equal to the capacitance here is x, microfarad. So I can say times 10 to the power minus 6 farad. Then multiply by V. V is already 100 based on what we see here. So 10 to the power minus 3 is equal to, this is going to give us 10 to the power minus 4 x. So x is going to be 10 to the power minus 3 divided by 10 to the power minus 4. This is going to give excuse me, 10, which is 10 microfarad. Okay, so we continue with the next one.